Everyone, just let's everyone trickle in before we kick off. But I came prepared today and got a pretty cool fact, I guess you could say, that I came across this morning. So slightly science related, I guess, but actually quite scientific. So among vertebrates, hummingbirds have the highest metabolism for their size, with a metabolic rate roughly 77 times that of an average human. They need to feed nearly continuously, but when it gets too cold or dark to forage, maintaining a normal body temperature is energetically draining. Instead, the small animals can cool their internal temperature by 10 degrees. Oh, phone just turned off, always good. By 10 degrees to 30 degrees Celsius. This slows their metabolism by as much as 95% and protects them from starvation. So a bit of a interesting fact to fill the awkward silence as people trickle in. Don't worry if you caught me halfway through reading a fact, you probably didn't miss anything important. Just give it maybe a few more seconds till the number of attendees plateaus out, which looks like it's starting to do now. So I might just wait a wee bit more. Okay, so welcome to day 2 of Brain Trust. Glad you can make it. And if you're not able to make it, hopefully you're able to watch this in the future. So hi to those in the future. Just to give some insights or some housekeeping for those that aren't familiar with Zoom webinars and weren't here yesterday. So there's a couple of ways that you can interact with the presenters or myself and fellow colleagues. So I probably should actually introduce myself first. I'm Liam Farley, one of the customer success managers based here in Dunedin in New Zealand, joined by Ariana Belay, who's also on video at the moment. She's based in America, and we've got Amy Boucher, does have an American accent, but not based in America, and based in our Dunedin office just down the road as I'm working from home. So as I was saying before, there's a couple of ways you can interact with your fellow attendees, the presenters, myself, and Ari and Amy. So one of those ways is via the chat function. So you should see that at the bottom of your Zoom screen. And importantly, there's two ways you can use the chat. One is to send messages directly just to the panelists, so myself, Ari, and Amy, and that's useful, I guess, if you want to say hi just to us, or maybe if you're having technical issues that you want to be having help with. Or you can send a chat message to both the panelists and or the attendees. So if you'll be broadcasting out hi to everyone, maybe letting people know where you're from, getting some discussions going, whatever you like. The other way you can interact with mainly the presenters is through the Q&A function. So you can open up the Q&A option and ask a question. And importantly, you can also upvote and comment on other people's questions, which is quite a cool way to get some discussion going. That worked quite well yesterday. So I really encourage you to keep an eye on the Q&A just in case you want to like a comment that someone else has done or ask a question. So there's also outside of LT on my brain, outside of Zoom, today we have the Padlet boards. So these boards that were set up for kind of asynchronous engagement. So if you want to be maybe notifying people of a cool resource you've come across or asking questions that maybe you thought of in the shower after today's event and you really wish you had asked them, you can use the Padlet boards for that. So I'm just going to quickly skip over to show you what they look like. So these are the Padlet boards. This is the main one that I'll link to in the chat so you can access it. You can link out to the other two boards here. So this one is just for like a general discussion board, notice board, so you can throw down what you want. We've already got some going already. So some discussion going on around online assessments, some people saying where they're joining from, a couple of other questions. So I really encourage you to use it however you like. There's also this other cool board where you can see where other people are joining from. So if there's maybe people in your neighborhood that you didn't realize were also Alta users, then this is a place to go and see. If you want to add a post, you can just click the plus, type in whatever details you want, whether it's just the country, city, or your institution, and it should appear there should just note that with these Padlet boards, they're all anonymous unless you have a Padlet account. So just keep that in mind. So maybe you want to add your name or your email address just so people know who's actually making the comments. And the final one is just around LT feedback as well. We always want to hear your feedback, so this is a great place for you to give that. All right, so I'm going to stop sharing my screen because I'm going to be bringing on our first presenter of the day who, oh, they're already coming in. Look at that, wow. We've got down to this to a smooth operation. So we've got Dee Silverthorn, who I think some of you probably know Dee. You might have seen her name on a couple of books around the place. And yeah, to be honest, doesn't need much of an introduction because Dee is just an amazing educator and I really look forward to hearing what she has to say. So I'll hand it over to you, Dee. Cheers.
Thanks. I am delighted to be here today with everybody. I see we have currently 70 people from around the globe. And I thought I'd like to know a little more about you all. So, Liam, do you have our questions set up?
Yep, so I'll launch a poll now and this should be appearing for everyone. And yeah.
There you go. There are 2 questions. So if you will just go ahead, you can pick as many as apply. How are we doing on votes, Liam?
We're at 40% now. I assume this is probably not the most important polling going on today as well. I hear there's another rather important poll happening, but let's not get into that. All right, so at 2/3.
All right. So let's go ahead and when we get a little more, you can close it out. Let's see what everybody says. All right, lab practicals, lab. A few people have had students design their own experiments, but less than 20% for content in lecture and homework independent review. So that was good. And then how have you used the content? Cases with some editing, that's about half of the people. And then combining, creating your own, and 34% have not yet used LT. So maybe we can convince everyone today that it's a great way to teach. So my talk today is designing lessons to promote problem solving and clinical reasoning. And I thought I'd start by telling you a little bit about my history with AD instruments. I actually started back in the early 90s when I had a grant from the American National Science Foundation to improve our labs. And I used the second generation of what was then Mac Lab only. It later became Power Lab. And we used this cute little computer on the right that was a Macintosh. And for those of you that haven't been around for, those of you that haven't been around for a while, it had a 40 megabyte hard drive with 2 megabytes of RAM. So you can see that we've come a long way in the time since. So our students use the Mac Lab to run their experiments, and they use chart, and they had to set everything up themselves and decide what the settings would be and filters and such. And so they spent a lot of time doing the mechanics of the experiment and not necessarily thinking as much about the experiment. So I was delighted in 2005 when ADI came out with Lab Tutor, where the experiments were already there. They had the settings. All the students had to do really was sort of plug and play. And it was great, but anytime you create content like that, somebody, including me, is not going to like it because it doesn't exactly fit what you want to do. And so I was very happy in 2008 when ADI came up with their version for authoring, which was called Lab Tutor. All Lab Tutor, Lab Author. And so Lab Author then was a way that you could take the existing Lab Tutor content and combine it or work on it to edit it. only it was not terribly intuitive. And so when finally in 2015, when LT came out, I was so excited because here was an authoring program that was so easy to use, and you could combine experiments and move things around. And so if you haven't used it yet for authoring, I think it's well worth the time to go in and play with it. Our students here in Texas call it CuraCloud because of the login being curacloud.com, but the product is actually LT. So with LT, it's very easy for the instructor then to go in and modify existing labs, combine labs, and now, and a number of you are doing it, adding pre-lab work, activities where the students are supposed to look at it before they come to lab. And I think Terry Sweeney yesterday talked about how he does that with his students. And we have actually gone with our medical students to where we gave them their own lesson that they could author and then share with the class to carry out the experiment. But as we were playing with this for the medical students, one of the things that I discovered was that it was really good for large group teaching. Um, some of you said you'd do it for outside of class individual work and assignments, but we actually ended up creating a number of lessons that the students work on in class. And then, of course, creating separate standalone modules for self-study and review. So what I'm going to talk about today then really is how we use it in the large group teaching, and focusing on the in-class active learning component, although there is can be pre-class work and post-class assignments. So to give you a preview, we'll first talk about evidence-based lesson design, how to design a good lesson for these in-class activities, and how to scaffold a lesson so that you can teach problem solving to your students. And then we'll mention, and I'll show an example of how you can use it for teaching content and a much more rich way than simply giving students a textbook. And then teaching clinical thinking and where to find resources. So those of you that know me know I've always been a proponent of an interactive classroom. And this is a photograph of my undergraduate physiology class in 2004. And you can see them holding up the uh, infrared pointers or clickers that they had to aim at the receiver in order for it to be received at that in that large classroom. So getting feedback from the electronic personal response systems was a wonderful innovation. But then it was clickers. Nowadays, here you see the students and they are in the classroom with their laptops, and this is our medical students, and they're doing small group work. So the question is, what else could we do with the small groups besides simply giving them cases to work on? So these, what I'll mention now is how you design a lesson based on what we know about how people learn. And this is one of my favorite books. It's getting pretty old, but two of the takeaways that we know from this book are that people learn best when they can practice applying their knowledge. And they need at the same time to get feedback. And it works best if it is ungraded or formative feedback. But there's also evidence coming out now, and Tony McKnight mentioned this in his talk yesterday, that they also learn best when they have an opportunity to make mistakes, and mistakes when it doesn't count. We don't want our health professionals making mistakes when they're in the clinics diagnosing. But if we can give them an unthreatening situation where they have a chance to make mistakes and get feedback and correct their mistakes, then what we've learned is that that's the information that they're going to remember. So this is a 2017 review that came out in the Annual Review of Psychology that talks about students and making mistakes. In the United States, at least, so often our students are afraid to make mistakes because when they are getting most of the time when they're being asked questions, it really counts. It's on some sort of summative exam, and it's either you're right and you get the points, or you're wrong and you miss the points. And so getting our students into the mindset that it's okay to make a mistake, I think, is one of the best things about doing this kind of in-class activity with questions. The other thing to remember, if you're doing this in class, and it came up a little bit in Rob Carroll's question yesterday, is how do you make the students participate? And the bottom line is that students are strategic. They're going to want to do something if they know it's going to help their grade in the course. And so I think if you're going to do this in your class, you need to make these formative assessments count, and not count for correctness, but count for completion. And so I will show you how we do that with the scoring in LT as we go through some of our examples. So getting the students to do it and giving them an opportunity to practice and make mistakes are critical. When I sit down to do a lesson, it's basically a form of backward design. So the first question is, why am I doing this lesson? What's the goal of the lesson? And I have two primary goals. One is either to teach content or sometimes to review content. And the other part is to give them a chance to work on tough topics. So, very often, the part that is teaching content or reviewing content is something that I might give as pre class work, or what we call pre work. And I would expect the students to do that before they come into the lecture hall. And then I prefer to spend the time in the lecture hall working on tough topics, things that are difficult for the students to understand, things where they are likely to form misconceptions. And so those are the goals of the lessons that I try to design. The next question then is, now that I've got the goal, what are the learning objectives? And I'm very explicit about them, and they actually appear on the first page of every lesson so that the student knows going into the lesson what they're supposed to be accomplishing. And the other thing to remember that's important is to think of Bloom's taxonomy, and your learning objectives should not just be simple recall questions, objective type questions, but should include some higher level questions and problem solving where you're asking the students to apply or analyze the material. And then once I have those things, it's pretty easy to start thinking of questions that I can create to test whether or not the students have achieved the learning objectives that I put at the beginning of the lesson. So I'm going to show you now an example of a lesson, and let's talk about how you scaffold a lesson. So scaffolding is a way of starting with the foundation and building up. So the first thing is going to be basic content. What is the content that you need to know to be able to work with this material? And some of that can come from the pre-work, but even if I've expected them to learn the basics on their own before class, I always start the lesson with a review of the critical basic content that they're going to need going forward. Then we'll move into some sort of analysis of the content, not necessarily anything very high level, but thinking about it a different way, looking at it from a different angle. And then finally, moving to application to see if the students can transfer what they've been working with now to something they've never seen before. And this can be a pathophysiology clinical example, or it can be an example from the research. So you're not restricted. It's strictly up to your imagination. So scaffolding is important because one of the things that it does that is important if you're going to be challenging students is it helps them build some confidence. So you get them through the basic content and they go, okay, yeah, I know that now. And then when they're challenged on the next step, they can remember, no, I knew the basic content. So she wouldn't be giving me this if I shouldn't be able to think about how to do this better. And the other thing it does is that it really is modeling for the students how you take information, how you start to analyze it and break it apart, and then how you take those parts of something that you had just memorized before and start applying it to new material that you've never seen. So one of the questions I've been asked is, well, you can do that in PowerPoint, right? There's no reason you can't do this kind of scaffolding and series of questions in PowerPoint. Um, and that's true, but the advantage of using lessons in LT over doing it in the class with PowerPoint and clickers is that it allows your small groups to go at their own pace. So if you have a group that is taking more time, then they can take time, and the other group that whizzes right through, I always make sure I have some additional problems somewhere for them to work on so that they can continue challenging themselves. So they sort of get the extra credit type of material. So the advantage then of using lessons in LT is the self-paced or group pace of the information and not waiting for the slowest people to answer with their clickers. So here's the example I'm going to give you that I'll show you some questions that pages I've written for the lesson. So this is a cardiac pressure volume curve. And we spend a lot of time trying to teach students how to read graphs. And then we throw something like this at them, where it's not the effect of left ventricular volume on pressure at all. You've thrown in a third dimension, which is time. Because if you start at A at the lower left of the graph, and then you move around in a counterclockwise or anti-clockwise direction, A prime, B, that represents the passage of time. And students struggle with this. So this is one of the areas then that I've chosen to write a lesson on for small group work in class. So we start with the basic content. Here's the loop, and this is a drag and drop question, and they are simply supposed to drag the blue options on the left over and put them in the correct place on the right. And as soon as they've moved one answer, the check answer box turns bright blue and they can start checking their answers. It's down and boxed in red. And when they check their answer, they see something like this, which shows them green checks for the correct answers and red X's for the incorrect answers. And at the bottom, when you're constructing the question, you have a chance to give them feedback or hints for how to answer correctly. So how do you set something like this up for formative grading? Because if you've got it for 5 points, 5 items to be matched, but they're wrong the first time, then they're not going to get all the points. And we don't want them penalized for being incorrect. So the way I set it up is I select, when you're writing your question, you go graded plus instant feedbacks. That gives them the chance to pull up that screen and see the checks and the X's of the answers they put. Then when you go to edit answer, this is the screen that appears. And what you can see besides the answers that you put in the feedback is you give it points. So I've decided 1 point per answer they do. But then you also give them multiple attempts. And essentially then they can keep trying over and over until they finally get all of the answers right. And so therefore, you're not penalizing them for being wrong. They've got a chance to get all 5 points. They just have to do it over and over again. So there was the first part of it, which was the drag in the upper right, the drag the answers. And then I asked them some additional questions. So the right-hand question says, which segment of the loop represents isovolemic ventricular contraction? And that means, have they learned that? That would be part of it. Do they really understand what the graph is showing? And then on the left, we actually ask them to read numbers off the graph and put the numbers with the units in the answer. And so this is simply making them work with the graph. It's not anything very complicated. Here's another way of interpreting, but this is a little more challenging because what I've done is I've taken on the left-hand side images of the heart during different phases of the cardiac cycle. And now they have to match what the heart would look like during each of the 5 indicated phases on the pressure volume loop. And so that would be a drag and drop question for them to answer. So again, it's content and understanding based, but it's not anything they could have memorized. They have to really know what they're looking at and be able to think about it. So from there, we then move into a pressure volume loop analysis. And this is a graph taken from a journal article looking at the effect of different levels of exercise on pressure volume loops. So the first question simply says, what happened if the blue loop A is normal person at rest? Now look at the loop B, which is the green one, and what's happened to the stroke volume? So again, that's just, can you read the graph? And then we say this stroke change in stroke volume is due primarily to which of the following. And now we're introducing new terms: preload, afterload, and contractility. So now it's asking them to transfer what they know about end systolic and end diastolic volume to the concepts of preload and afterload. So a little more challenging for them. It's not directly something they would have memorized. And then as you finally hit the most strict or the most difficult for them is to give them figures they've never seen before. So my students had never seen anything like this before, and they are told that this graph, the red graph, which is an abnormal one with the normal in black, represents either left ventricular heart failure, aortic stenosis, or mitral valve stenosis. And so they are to work together, analyze the changes, and which of the pathologies is it, and explain how you got to that conclusion. So, one of my rules of thumb when writing these lessons is, whenever possible, to avoid using multiple choice questions. With less, our students are so good at taking multiple choice tests. Almost all of our high stakes exams, both at the medical school and at the undergraduate level, are multiple choice, and their national board exams for medicine in the United States are also multiple choice questions. So students learn that if they've memorized enough, there's going to be enough content in the STEM and the distractors that they're going to be able to recognize the information. And they've never learned to retrieve the information just out of what they know. So that's one of the reasons that I would avoid multiple choice questions when possible. And then here's another example of a different set of pathological pressure volume loops. And again, they're asked questions, and they're also asked, in this case, to do some explanation for the question. So this is the kind of scaffolding where we started with the basic loop. Look at how it's constructed. Make sure you can read it. Now let's start thinking about it and applying it. The other thing that I like particularly about LT is that I think one of the things that we often don't do enough with our students is ask them to draw things. They can recognize figures, but if you ask them to draw something de novo, very often they can't do it. They just can't do it. And so with the annotate feature in LT, you can have the students actually then start drawing. So this is an example. And here it's asking the students to draw the curve in acidosis. And this is what the annotate screen looks like. And the blue line is the hand-drawn answer from the student. You notice that on the left-hand bar, the students have 3 different options. They can put arrows in, they can draw freehand, or they can actually type text, and that leaves you a lot of options for different questions. And they also have multiple colors, so you could ask them to do the response, the change in the curve in acidosis in one color and alkalosis in another color. The other thing I've learned the hard way when watching students in class is that I'm very explicit about when you get to this point, there's a little done button down there because very often they don't know where to go and they get stuck and get frustrated. So here's another example of a draw it that I give them in class, which is draw the left ventricular volume curve when end diastolic volume is 135 mils and end systolic volume is 65. And they're shown across the bottom, the hearts that state at the different stages. And again, this is a graph they've seen. It's actually part of the very complicated Wiggers diagram, but you're trying to get them to think through it. And just to give you a clue, the easiest thing for them to do is to draw the end diastolic volume and end systolic volume during the isovolumic phases. And then once they've put those in correctly, it's quite easy to connect the dots. And then here is another example. This is actually something I asked them to do, which is to draw their own left ventricular pressure volume loop. And I give them some numerical values, but now they have to use the annotate feature to put the labels on the axes, to put the numbers on the axes, and then to put the points on that I gave them and connect those into a loop. So you've got all sorts of options for using annotation, but having them actually draw it makes a big difference in their performance. So I wanted to show you some examples. I mentioned teaching content, and often this can be done for individual work at home, but we do some of it in class if it's content where they're having trouble. And if you saw Amanda Charlton and Diane Kenwright's presentation yesterday, you know they were talking about how difficult students find histology, that all that stuff is pink and purple, and how am I supposed to know what it is? So we created a content activity for leukocyte identification. And the difference between this and simply giving them a book is that you can combine it with the practice and the feedback. So a typical book might give them the content you see in the purple box here, along with a figure. But one of the things that research has shown using eye tracking software with students is that students don't look at figures. They tend to just skip over the figures. I don't know if they think they're pretty or what, but they just ignore them. So what we do then is we add questions that ensure that they're going to look at the figures. So this question asks the students, how many segs are identifiable in this figure? So they actually have to really look at it. They have to read the definition and the description of what a mature neutrophil is, and then actually look at the figure. And then on a previous page, they learned about lymphocyte. So we also ask them, what's that cell up near noon on the figure? and they should recognize that from previous pages as being a lymphocyte. So you can give them recall practice as well as forcing them to look at figures by structuring your content with something active for them to do. Teaching clinical thinking is something that we've had a lot of fun using LT for. And again, this is a place where it's really important to not give them multiple choice questions. Um, Patients are not multiple choice questions. They don't come in and give you options for what their diagnosis is. And so having the students give free response answers is really important, and making them explain their thinking, because too often they can sort of either by accident or something subconscious hit the right answer, but they can't explain why they got there. And you may have seen Andrea Dillon's presentation yesterday about how she uses case studies with LT. And I will refer you to that because she goes into a lot more detail than I'm going to, but we had many of the same things in our presentations. Here's an example where it is a multiple choice question. It's something that they might see on one of their summative exams. But in addition, you make the students explain their reasoning. And that way they can find out whether they got the right answer by accident or intentionally. And as you saw in the, if you saw the production yesterday, the case studies are easy, and they can actually be used not just for presented cases, but we have used them in our physical diagnosis class where the students are actually learning to do their physical exams and take a history and such. And we leave free response boxes. So you may have trouble reading it, but the boxes at the lower left say, list your 3 most likely diagnoses based on the information you have so far. What additional history would you like to get from this patient? And what lab tests would you like to run? And having students put in free response questions like this can be very valuable, because when you go back and you look at it, especially if it's formative and you don't have to go in and grade them, but you're going to find out that there are certain incorrect answers that show up over and over again. And you're also going to see certain misconceptions that will pop up. And so by collecting free response answers like this, you can actually use these common incorrect answers to create the distractors for your multiple choice questions. And so you actually, in a way, get the students to write your multiple choice questions for you. If you've not seen them already, there are a number of clinical cases that are in LT, and they're quite extensive. They're long, they have multiple videos, they've got lab results, they've got imaging. They're very, very rich in the amount of content they have. And so this is a case where I took, this is Barry West, and he's a gentleman that had a stroke. And so I took the content from his case and edited it down to the critical information, plus a bunch of extraneous information, which is going to happen anytime you have a patient. And then the students are asked what brain regions might be involved in this episode based on the clinical findings. And the students write their answers in and have to commit them. Then we have them look, here is a CT of Mr. West, and they're asked now, based on what they had previously said, to see if they can find the abnormal region in the CT scan. And this is done in annotate, so they would get the drawing tool and circle it. And then when they check their answer, they can see, if you look in the lower right, you can see the red outline around the part that's abnormal. But now you have a question to ask, an opportunity to ask a follow-up question. So, what artery or arteries are most likely to be involved in a stroke in this region of the brain? So you can actually combine and give students a sense of the importance of their anatomy and physiology as they're seeing these real patients. Um, this is one of the videos, the case study videos, and Tony actually did part of the interview with this lady, Mary Montgomery, yesterday. But another possibility is to take a video clip and it shows her walking down the hall. She has COPD, and then she stops and she's struggling to breathe and she's doing her pursed lip breathing. And so show students that and ask them to explain the physiology. Why would breathing this way help improve her ventilation? So there are lots of opportunities to do creative things with the content that's in the LT case studies. So where do you find resources? Well, the LT patient case library has about 30 patients in it with different conditions. Um, Another place, if you've not already discovered it, is the journal Advances in Physiology Education, which is put out by the American Physiological Society. And it is online and it's free, and there's the URL. And the speaker following me is one of my colleagues, Jennifer Stokes, and she is going to talk about a case that was published many years ago on paper in Advances that we have adapted then into an LT activity. For case studies, and particularly for case studies that are not medical case studies, there is a group called the National Center for Case Studies in Teaching. And this is their website, and they have a whole bunch of cases there. And many of them are on introductory biology, ecology, areas other than anatomy and physiology. And you can read the cases free if that's all you want. But to get access to the teaching notes and answers, they have to certify that you are an instructor and not a student going after the answers. And then they're now charging a fairly minimal fee of $25 US per year. And then finally, and you've seen examples of this in the lessons I showed you today, just look at books, not necessarily the textbook you're teaching from, but look at other books, more advanced books, or just a different book sometimes, or go into the research literature and look at graphs and find figures and write questions around them. So anything that you might throw up and say to the students, look at this, the results of a study, turn it into a question instead. Just simply turn it on its head. So, in summary, I hope that you will consider, if you've not done it, creating lessons that challenge students and that give them feedback and that give them an opportunity to make mistakes in an unthreatened situation. And to get their buy-in, have it count for something, make it count for their grade. Start with your learning objectives and then scaffold your lesson so that you build from the basic content to the more challenging applications. And do take advantage of the different question types that you'll find in LT and avoid just straight multiple choice questions. And it should be fun. I hope you'll enjoy it. I've tremendously enjoyed the opportunity to create this kind of content for my students. So I think we'll probably have questions now, but I wanted to say a big thank you to Tony and Michael McKnight, who founded ADI, who have been so supportive through the years, and Amy Simpson Boucher, who I have known since she was Amy Simpson and my very first rep. There she is. Hey, at UT, and she is the one that when they had Lab Author, and every time I couldn't figure out what I was doing with it because I'd been away from it for too long, she was there on the phone and providing great support. And then finally, all my students and colleagues through the years, because I love to play and they have been the victims of my playing. So, Liam, I haven't had a chance to look at chat or anything. I think you're probably going to tell me what's going on.
Yep, sure. First, I obviously want to say thank you for, as always, amazing talk. I'm sure there's plenty of applause going on in the background. Yeah, thank you, Amy, for silent applause. Yeah, unsurprisingly, there are many questions that are coming in, so we've got about 15 minutes to cover them, so hopefully that should be enough. Just wanting to check with you first, Dee, do you prefer to read the questions yourself, or would you like me to read them to you?
Probably, why don't you read them to me? I think that'll probably be easier.
All right, I'll put on my reading voice. And sorry, I turned my video off before. I was having a bit of a coughing fit, just kicking a cold. So apologies in advance if I cough. So the top rated one is from Aura, who presented yesterday. So she says, Dee, now that most of our students are working remotely, we are struggling to get students to work in group. Freshmen here. Any advice on how to get students to get excited, engaged about completing lessons as groups? So much learning happens in teams, and we are struggling to get students to stay on the Zoom and engage in group work. There's a few comments below that, but I'll let you mull that over and then I'll read the comments after that.
Well, I think Rob Carroll asked the same question yesterday, and what we have tried that seems to work is to we use Zoom and we send them to breakout rooms, and we give them they have to assign someone a task, so timekeeper, scribe, and a leader. And then we also often will give them an assignment to complete in that room. And it's very short. They are really good at using Google Docs. So they'll go in and create a Google Doc for their room and answer the questions, put everybody's name, and then we require them to upload it into Canvas, which is our course management system, within an hour of the close of class, so that they actually have to have a product that they are turning in somehow. And I think that makes having a product seems to force them to focus a little more.
Yeah, I agree. The comments that were following on from that, first one is from Daniel. So saying, same experience here, have been using Zoom breakout sessions, and I can see that the group work quickly turns into subdivided individual work, parentheses, I'll do the odds and you do the evens. And there is little discussion without significant prompting on the part of instructional staff. Definitely agree with that. So yeah, a couple more comments. I am also struggling a lot with this. This is from Vicky Dunk, by the way. I have set activities for them to do, but they will not do them together in the breakout rooms. You go in and they're working independently or waiting for the answer. And Aura again, commenting on her own one, our kids sometimes leave while on the breakout room, even when they have an assignment to complete. So I'm not sure if you have any thoughts or suggestions around those comments.
I think, I mean, the comment about I'll do the odds and you do the evens sounds like, and I don't know that this is what it was, but that you need to give them something that is more challenging. I mean, versus something they really need to discuss, and save the comment of the objective content for pre-work or even a post-class follow-up. Yeah, I mean, it is a huge problem. I have a colleague teaching intro bio, and he keeps giving the students the same question on test, and he talks about it in class, and they keep missing it. And it's, I think it's the student attention has become a real problem with Zoom. But we try and use something creative and something fun. I mean, the whole issue of assessment with remote learning is a huge one.
Yeah, I think there was actually in one of the Padlet boards, there was something that had a few comments on that around assessment. I might just stop your sharing just so we can, it feels weird looking off to the side, might be a bit nicer. Yep, so there are a few more comments.
You stopped it, okay.
Yeah, sorry, I have all the power.
Okay.
Just aware of time, there were a few more comments on that, but I might just skip over to the following question. This is from Diane Kenwright, who presented before and you gave a shout out in your talk. Her question is, what do you find the ideal length of lesson when the students are working, 1, individually outside the classroom, and 2, in groups in the classroom?
Individual definitely need to be shorter, but we probably keep our lessons at maybe 10 to 15 maximum pages. I mean, usually what I showed you for the pressure volume loops, I wouldn't even have all of that in the lesson. I might have I might have one of the 2 pathology questions in it. So for, one or 2 basic content, 1 or 2 application, and 1 real pathological application, and keep it short and simple. They do much better if it's short. That's what I found.
Yeah, it's a good rule of thumb, that. All right, and then Amanda coming in, again, dynamic duo. So Amanda's question is, Dee, for your open text student answer area, do you read the student answers, or is this just to prompt them to do activity?
Both. We asked them to do a report at the end, or I have the reports at the end automatically sent to me, and so I will see them. Do I grade them and comment on them? Not necessarily, but very often, if I've looked at the reports that have come in and I see there's a particular misconception that's cropping up, now I have something I need to talk to them as a whole about. So it gives you a handle on where they are, where they're having trouble. So I read them, but I don't necessarily grade them or comment back to the students individually.
Yeah, that makes sense. And yeah, Daniel just commenting on that as well. Similarly, how do you manage providing meaningful feedback for short or long answer style questions for large courses?
Well, they have the feedback in the question. We put the feedback in the question, and then we have 1 hour a week tutorial sessions. And so again, if there's something that I think that I'm seeing needs a lot more feedback, I may create another problem that's related, and our teaching assistants run our tutorials, and then have the teaching assistants do it, so that the students then are getting something similar, and they get some feedback in that one-on-one, and some of those are actually face-to-face now. Even though the big class is Zoom, the tutorials, if the teaching assistant wants to, are face-to-face.
That's useful. Diane again. So if you use completion to award points, do you have a separate test to assure competencies have been achieved?
Yes, that's our medical students, where that you were seeing. Those were lessons I did with our medical students, and they have a midterm and a final exam that are all multiple choice based test. And so that's the best chance to find out whether or not they've actually gotten it or not.
Yep. All right. So it's very rapid fire questions at you, if that's all right. So we got Terry, who also presented yesterday from Scranton. So how are you constructing your graphics for your LT pages?
I actually do mine in PowerPoint. I've actually gotten pretty good with, not with freehand things, but anything that is literally a graphic. And then you can save it as you can save it as a JPEG. Even some of the publishers are accepting PowerPoint figures now as images. I know the Springer Nature, we have a book program with them, and the APS does, and they take PowerPoint figures. So PowerPoint's becoming sort of the alternative to having something like Illustrator.
Yeah, I remember doing all my images for my master's thesis in PowerPoint. So yeah, I agree. It's very useful. All right, so we got one from Ricky. Very much enjoyed your presentation, Dee. Thank you. And at what point during a face-to-face class would you have students discuss their answers with you and their classmates?
So often what I'll do is with the medical students are different than our American undergraduate students. For those that may not be familiar, our medical students are all post-baccalaureate students. And so they often, when they've finished a set of lessons, we come back together and I may say a few words about common mistakes that I've seen, but for the most part, they're happy to have worked in a group and they ask the questions. We rotate in the classroom throughout the class as they are working. So a lot of their questions get answered that way. And then I may pull them back and give them yet another question or example to work as in a big group. And we also have clickers for them as well. So I can do that with the traditional clicker and see that if they've gotten the material. And I'm not sure that answered the question.
I'm sure Ricky will come back if she wants further clarification. So another 5 minutes is a few more questions. So this one from Ahmed. Our big challenge to develop formative assessments during big class time is time. We have to deliver several learning objectives in a single class meeting. While it takes a lot of time when we stop to discuss one topic of formative assessment with the students, how to solve this?
I think the way to solve that is to decide what the students can learn on their own. And that's basically what I've been doing with my classes for a number of years, which is they have a reading assignment and they've got what I call reading questions, which are the lower level learning objectives. So things like list, define, describe, explain, even some lower level compare and contrast. We tell them, you need to get this on your own before class and provide a quiz, a short graded but open book quiz before they come to class. And we say, any questions over that content? And if there are no questions, we jump right into the higher level learning objectives.
And I should also point out as well, on day 4, we've got a presentation by AD Instruments Career and Charlotte Steele, who does talk about Bloom's taxonomy and stuff as well. So just for those listening, that's probably a good one to attend. So next question from Burhan. Should we worry about students looking up answers for some of the LT content? Does it help anyway, even if they Google the answers?
Generally, I mean, part of the trick is to do something where they can't easily Google the answer. I mean, that's, so that graph with the 3 pressure volume loops for exercise, they're not going to have time to go look at the paper and read the paper and decide what it's doing. So part of it is creating something that's not easily Googleable. Is that a
Yeah,
word?
that's pretty sure.
So but no, I mean, that's reality. Even the clinicians in the clinics, they all have their smartphones or their tablets and they're looking things up. I mean, the question is what's critical for them to be able to do without assistance and what's critical for them or what can be okay for them to look up. And so the trick is writing questions that challenge them in a way that they can't look it up.
Yeah, which takes time. It's pretty tricky to do, but definitely useful. All right, 2 more questions in the last 2 minutes. So Terry again, is there an issue in using figures from copyrighted materials? My understanding, if it's for a single class, it's okay. So I guess you can try and answer that one if you want, Steve.
Uh, yes, I mean, if usually as long as it has been behind a firewall, and our university has a policy that goes in our syllabus that says any content that is presented in this class is intellectual property and should not be shared in any way, shape, or form with anyone by any medium. And so it is in the syllabus, and that then becomes an academic issue if they're found taking these things and distributing them around the internet or sending them to some of these websites. But it's really hard to control.
All right, and last question from Carlos. So he's a professor in vet physiology. Do you know of any experience in which LT aids have been adapted in this area? That's potentially something I could actually speak to.
Yeah, you should. You should.
So yeah, Carlos, I'll follow up with you later on that. I see Steph has jumped in on that. So yep, looking at the time, we've come just on the hour. So I want to say a big thank you again, Dee, for amazing talk and for the answering of quite a few questions. So cheers for that. And I'll drop you back down to being a panelist and bring on our next presenter, which you have thankfully actually introduced already, but just again, it's Jennifer Stokes.
Yeah.
So bear with us as we just switch things around. Thanks, Dee.
Bye.